Today, we want to put the spotlight on insert design for molds. How best to design inserts is a common question we get on the tech support line, but it isn't one with a quick answer. The fact is, there are several good ways to design inserts, all of which have a use depending on the situation. One might be better suited for early in the design process, and one better suited for later on. One works best with off-the-shelf standard parts, and another works best for custom shapes. You really want to be familiar with all of the design tools so that you know which one is the best choice when you design your next insert. We're going to look at three different methods for designing inserts for tooling. Doing this requires trying out several functions that you'll find in the dedicated Inserts menu in the Mold Design toolbar. Hopefully this will illustrate the pros and cons of each method and help you make better, faster mold designs. The first insert option that we'll look at may be an obvious one, but let's not forget that while you are splitting your part, you can divide it up into as many groups as you want to. And each of these separate groups of part surfaces will get exported to its own mold component, which means Quick Split is actually a great tool for defining mold inserts. Of course, usually you aren't thinking about little mold inserts when Quick Split is being used at the very beginning of the job. This is generally when you're thinking about the main cavities and parting lines. But if it's an obvious area or a larger area that you know from the start will need to be inserted, defining it in Quick Split is actually a very nice way to go. Because this part has already been split into cavity and core, all of the part surfaces are already assigned. But Quick Split will let you pull in the same direction more than once, and it will also let you reassign faces that already belong to some other group. I'm just going to first unstitch a face, which is a good trick to take advantage of the rules that Quick Split operates by. And what I mean is that Quick Split does its analysis by following the solid topology. So unstitching that face basically created a boundary. The new split area will stop when it gets to the edge of the solid. Just be sure that the option to ignore already assigned faces is off and you can define a new group. The motion direction doesn't really matter here. What matters is that the part geometry that belongs to the new insert has been added to a new set. While in the parting area, you can also create parting surfaces for your insert group. What these become, of course, are the walls for the lower portion of the insert block. As there is only one other area that needs some shutoff work here, I might as well do that now too. One of the Cimatron parting surface functions is a very strong cap internal islands tool to extend and join the faces of internal openings in the part. It's a very automatic solution for an area like this. Parting surfaces get attached to two quick split sets. So what automatic attachment will do here is take the insert walls and also assign them to the core side, so they'll become the insert pocket. This is a nice advantage of using Quick Split for inserts, creating one surface that does two jobs. The cut active function is used to create mold components from Quick Split sets. Usually you pick a target part or plate, but what if that target part doesn't exist yet? Well, you don't always need a target part. Cut active works great to create new parts on the fly. Just change the option, pick the subassembly that the new part will belong to, and give it a name. The rest of the function works the same, except that the option to cut will not be available for new parts. It'll do an import instead. And import is all you need in this case, as the work we did in parting basically completed the entire insert, except for maybe a face to cap off the bottom. Adding that finishes up a nice mold insert, and the core plate will have a matching pocket shape that can be wire burned. Because this type of insert was defined in Quick Split, it can be updated from parting like any other major component. When the work file changes, the cut feature will get a notice and then can be directly updated. Once the mold design is farther along, it becomes a lot easier to see geometry in the cavities that would be better designed as an insert, either to make manufacturing easier or provide a vent or some other reason. So let's now look at the specialized tools that Cimatron developed just for inserts. The first one to look at is adding and cutting an insert from catalog. All that insert from catalog really means is that you want to place an insert blank from a standard component. A perfect example of this is designing core pins. All of the insert specific functions are grouped into their own menu. A few of them, like sketch or add new part, are really just general assembly functions that you can find in other menus as well. But add insert from catalog is unique. It opens up the catalog part browser. Here you specify the supplier, like Hasco or PCS or any other. Then select the filter that gets to your part. Most catalog parts have a full table of sizes to choose from, so find the necessary diameter for the area in question. Core pins are especially easy to place in the correct location because you can just reference the true circle center of the part feature. Also, in an add operation with multiple parts, you have to decide if they should be all the same component or each its own component. These pins can be all the same because the shape is the same in all three spots. Most catalog parts have a cutting object too, so be sure to use the with cut option. So now we've got 3 core pins in proper holes. But the part geometry, the stuff that needs to be on the core pins, got erased when the holes were cut. So clearly there has to be another step when you use add insert from catalog. And there is. You next need to use the cut insert function. Cut insert is quite simple. You start by picking the insert that needs cutting. At the second step, you're prompted to pick a split direction. And that's the key here. You put the shape on the insert directly from the work part. All you do is pick a face in the appropriate area. The function then decides which part and shutoff faces are needed to finish the insert. Getting the shape on the insert directly from the work part, as opposed to taking it from the core block, is really ideal because it's a direct connection to the actual part. This is the best situation to have when the molded part gets changed and the insert has to be updated. Next, let's look at the function you might just use the most for inserts. The add insert function creates inserts directly from the existing mold components you have. It has a lot of options, so can sometimes seem confusing, but really it can work in almost any situation. For example, the tall, thin area on the main insert looks like it should be an insert of its own. At the first step of the add insert function, you decide on the geometry that will belong on the insert and which subassembly of the mold the new part will belong to. Let's create this one by choosing reference faces. When using this option, the system also assumes the subassembly for the new insert based on where you selected. At the second step, you can set the insert depth or just go through the source part. And there are several optional steps in the feature guide. You can add a taper angle on the insert, or put an offset on the cutting object that will make the pocket, or check the status of the parts that will be cut by the new insert. So the add insert function does a lot of things. It creates a new part in the design, it transfers existing geometry over to the new part, and it automatically creates an insert body that also serves as a pocket in the original part. Next, I'll use the add insert function again on the other side of the tool. This time, rather than selecting reference faces, I'll try out the option for 2D contour. If you don't already have the contour for the insert area prepared, you can just make it now. Use the composite curve function to change some of the part edges. Or you can use sketch and create whatever perimeter you really want. In this case, I'm going to use a few of the part edges, plus draw a line so that the insert is a square. I did mention that this function has a lot of options. Using the 2D contour method is what gets into most of them. The first one is about how the shape gets on the insert, the source of the geometry. It can be from the parting area or from selected faces. The default, however, is by object, and it requires you to select the source object. That's not assumed like it was when we made the first insert from reference faces. Next, you set the depth. Because I made my sketch in the middle of the area I'm inserting, I have to give a distance in the direction of the arrow plus a direction backwards. I can put in any number I want backwards as long as it goes past the surfaces involved. Another option on the screen is for relieving corners, but I can't use that here because the insert is completely inside the plastic molding area. And the extract option is for use when the sketch isn't made right on the geometry. Always remember that if you have any questions about what all these options do, you can hit the F1 key and get the help screen. This gives you a good explanation of all the different parameters. So you can see that the new insert was created from all of the geometry that was found inside the 2D contour and within the depth setting numbers. In the cavity, a pocket is left behind. This insert gives me a chance to talk about the wedge function. Wedge is for automating different types of heels on inserts so that you don't have to add a screw to hold it in place. Start wedge off by picking the bottom of the block. This function also has a lot of options. The preview is on, so you can see how changing the different parameters affects the shape before you approve it. The global heel shapes are round or box or an offset based on the insert shape. But the wedge doesn't have to be on all of the edges. There's a toggle to local if you just want to pick single edges to have the heel on. There are sub options here too, like clamp support. Clamp support makes an entirely new shape off to the side and is really specific to die making. That's probably not a common one, but the normal option is a good one to use if wedge is going to be on multiple edges. Variables for this type of wedge are the inside or outside corner rounds, plus an offset distance to control how far down the edges the new wedge shape will go. The extra material on the insert is going to mean that the pocket in the cavity needs work too. Happily, the wedge function handles that also. Just go to the optional step of the feature guide to see the cutting object parameters. You can add clearance to the top or sides and then just approve everything. You won't have to ask for the cut or pick the cavity block. The wedge pocket is automatic as long as you're using the cutting object option.